Okay. So for this combination, I'm going to write it as A bar B C bar, and for this A bar B dot C, and for M6 combination it is A
A B C bar.
C bar.
ABC bar.
Yes, correct. And
A
then
B C.
ABC.
right. This is now okay. This is what I have got, some product terms or min terms for these inputs. Okay. Now, before going to implement, what I have to write? I have to write SOP form. Okay. SOP form of this. What is the SOP form of this function? F of A B C equal to, what is the SOP form?
A bar B C bar plus B C bar plus A bar B
Yes.
C
Yes, correct. A bar B C,
A bar BC.
plus A B C bar
Plus ABC.
A B C bar.
Plus
A B
ABC.
C.
Correct, correct. Plus A B C. Okay, you just understand I have not put any dot here. If I don't have put any sign here, it means it's a dot product. It's a product. Okay.
Yes.
Okay, fine. So this is my equation I have got from this truth table. Okay, that is what we are learning now. We are understanding now a generation of switching equation from the truth table. So once I got the equation, okay, switching equation from this truth table, then I am able to implement the output. Whatever the output I have got, if I want to implement this function by using the logic gates, I require a Boolean equations, switching equations. So by using these equations, I am able to implement my design. Okay. Now how I can implement this? For to implement this, what I require now? What are the basic gates I require?
OR gate, AND gate,
As well as not gate.
not gate. Yes.
Okay, it is called as AOI. AOI. A is and, O is or,
Or
I is
not.
inverter, not gate. Okay, so these types of circuit diagrams or logic diagrams are called as AOI diagrams. Okay, AOI means you should understand that it is AND gate, AND logic or logic inverter logic. Okay, even if I go for a POS form of this, then also it requires AND gate, OR gate,
Inverter.
NOT gate, inverter.
Inverter.
Yes. Okay. Now, how do I implement this function in terms of the gates, logic gates? Now, okay. What is the first term? A bar, B, C bar. Okay. Now, what I will do? Simply, I will put one line here. I say that this is A line. Okay. Because in the third term, I require A. In the fourth term, I require A. So this is the input side. Okay. Now I will take one more wire here where I will make the inversion of this wire. This is one wire. Okay. A wire. I will take one connection here. I'll put one NOT gate here. Is this NOT gate?
Yes, sir.
Okay. So what is the output of this NOT gate now?
A bar.
A bar. Okay. I will take one more line here, which is B. Simple B, 1. Okay,
B.
this wire is B, right? Now I'll take the connection to the NOT gate. What is this line? Second line here.
B bar.
Then again, this is C. I'll take one more line here. NOT gate. And this is
C bar.
C bar. Okay. Now, okay, now what I'll do? What is my first term? A bar, B.
A bar, B, C bar.
Okay. I require what here? The AND gate. Correct? To get this first term, I require NOT gate as well as AND gate.
And
Okay. So, what is the input to the AND gate here? A bar is the input, B is the input, C bar is the input. Okay. So, I will take one AND gate here. Eraser. So this is an AND gate, okay, output. Then, what are the three inputs for this AND gate? A bar. A bar
A
means
bar.
I have to take this line, correct? This wire, the output of this
Yes.
bar. So A bar. Then
B.
B. From B, I'll take a connection. And C bar.
C bar.
No, C bar. Okay. Right? Now, to get only one term, I have used a NOT gate and AND gate. The output of this AND gate is A bar, B, C bar. Okay. Then for the second term, which is present in this function, again what I require? One AND gate. Then what are the inputs for this AND gate? A bar,
A bar.
then B,
B.
then
C.
C. Okay, understanding? Like this, I require another two AND gates for this term and for this term. Okay, at the end, what I am going to do? I am going to add all these outputs.
Yes, sir.
Correct? Suppose think that this is the third AND gate and another fourth AND gate. These are the outputs of 4 AND gates. Okay. Now what I require for addition of this?
OR gate.
OR gate. So what I will do? I will connect one OR gate. My drawing is not so well. Don't mind. So I will give all these inputs to the OR gate so that all these product terms will become sum of products at the output side. That is our F, output F, A, B, C. Have you got this?
Yes, sir.
Okay. So now if I am going through this step, this is the first step that you must understand. Okay. If you have cleared all the doubts till this, then it is very much good for your future so that you can design many other logical circuits. Okay. A combinational logic circuits, sequential logic circuits, they will go later. But first of all, we should understand what is AOI and OR and inverter. Okay, so here I have just put whatever I have got the output. Okay, if I go for this same output for this expression, it will be very complex for me to design such kind of right now I have designed such kind of logic diagram, logic circuit. It is very complex. If I just got the output expression and suddenly I have implemented the diagram. Suppose here only three variables are there. So, somewhat I have implemented the logic diagram very easily. But if I have four input variables or five input variables, then I may get many number of product terms. To implement that product terms, it will be very complex for me to draw or to design the logic circuit. That is why another main important topic for this is K-maps, or also called as Karnaugh maps. So what is the main intention of this Karnaugh map or this topic is to minimize.
Minimization of Boolean.
Yes. So K-maps are useful tool for Boolean function minimization. To minimize such kind of bigger expressions, K-map is very helpful and very quick. Okay. Sorry, someone is asking anything? Shivanand? Okay, fine. So K-map is very much important to reduce a bigger expressions, a larger expressions. Okay. So K-maps provide a graphical methodology for minimizing the Boolean functions. Okay. That is via the pattern recognition. This is the main important. Whenever it is being asked, what is a K-map? So you should tell that the K-map is a graphical methodology for minimization of the Boolean functions. And that too, how means by a pattern recognitions. Okay, pattern recognitions. How we will do pattern recognitions? That is an important point here. Okay. So for larger numbers of variables, there are so many computer algorithms are there. They can execute all those algorithms and solve the larger variables. But only for 4, 5, 6 variables, we can go for Karnaugh maps, and that too by manually. We can go for manual using K-maps. K-maps are a way of expressing truth tables to make minimization easier. Okay. So for easy minimization purpose, we go for K-maps. How these K-maps are going to help? Like, see, there are two variable K-maps. There are, it is going to provide us from up to 6 variables. If I have 6 variables like A, B, C, D, E, F. Okay, just think that I have only 3 variables here and I have got 4 product terms. If suppose the output is here also one, here also one, then I might have got 6 product terms here. Okay, 6 product terms. Then if I have 8 variables, sorry, 4 variables, A, B, C, D, then also the expression, the product terms are going to be increased based upon the input. The function is going to be changed according to that. According to that, the product terms are also increasing. Okay, if I go for a 5 variables, A, B, C, D, E, then again it is increasing. If I, that is what, until up to 6 variables, this K-map is going to help me. Okay, but more than 6 variables, even through manually, if you want to do, it will be very lengthy as well as quite complex. So there are so many computer algorithms are there to implement such uh, variables, more than 6 variables. Okay, so we'll see, for one variable we don't have K-map. It is very easy to write the expression for only one variable. If we have, that is what we will get, maximum A bar or AB, uh, A or A bar for only one variable. If I go for 2 variables, then I will get, I will be having 2 variables, A and B. And how many uh, combinations I will get? 4 combinations. Okay, how do I represent those 4 combinations in a graphical methodology for minimization purpose? By using a pattern recognition. That is what, here you can see the diagram. Now, so for any variable, first of all, we have to write the variable values. This is the example for 2 variable K-map. Okay, the number of cells in 2 variable K-map is 4, right? See, total how many cells I have? 4 cells I have. Okay, I have 4 cells. For what variable? For how many variables? For 2 variable K-map. Understanding? For 2 variable K-map, I'll be having 4 cells. That is nothing but, as I am going to get 4 combinations, 1 cell for 1 combination. Okay, so I have 4 combinations. I'll be getting 4 cells like this. Either I can go for column wise or row wise or like a square like this. You can see here. Okay, what are the inputs? For that purpose, I have to write one side one variable, another side another variable, like A, B, or Y and Z is being written up here. Z is one variable, Y is another variable. Okay, if I go for Y and Z as an input, what are the combinations I will get? 0, 0, 0, 1, 1, 0, and 1, 1. Okay, now what is the term I'm going to get here? It is min term. Let us go for min term. Y bar, Z bar. This is for this Y bar, Z. This is Y into Z bar, and for this Y into Z. These are the terms that I'm going to get. But now, how these inputs are mentioned here? So this Y is going to vary from 0 and 1. That is it. Y is either varying 0 or 1. What about Z? Here only I have at the uh, adjacent of this bar, which I have drawn here. In the downside, I have a z, a y, and in the upside, I have a z variable. Now, what are the variable values that y is going to vary? It is only one variable. It will vary only either a 0 or 1. So like that, z also is going to vary either 0 or 1. Okay. When I am going to mix up this y and z, what are the combinations I will get? 0, 0 and 0, 1. Again, 1, 0, 1, 1. Okay. There are four cells that are, these are four cells that are going to connect this y and z. Now, how it is going to connect? As I said, the y is 0 and z is 0. The cell number is M0. The y is 0, the z is 1. The cell number is M1. Okay, that is what I have here, y bar z. Then, so two cells are over, another two cells. Y is now going to change for next combination. Y is 1, z is now 0. The combination is third combination, M2 cell. And then y is 1, z is also 1. Which cell I will get? M3 cell. M0 cell, M1 cell, M2 and M3. Total 4 cells. Okay. Either I can go for this type or I can go for this one, where I am writing the YZ in the upper side only. Okay. In the with this adjacent, I am not dividing the variables. I am just including, combining both variables here. So what are the variables combinations I will get? 0, 0, 0, 1. Here we should understand that the first term, when I say YZ, the first value is Y, the second value is Z. The first value is Y, second value is Z. Okay. 0, 0, 0, 1, 1, 0, 1, 1. Oh, sorry, 1, 1, 1, 0. The only difference that I have to write here is, first I have to